Hey everyone, welcome to Lesson 5 of ESP32 Pixel. In this lesson, I'll show you how to use Squareline Studio to design the UI for your product and import it into your code. In this lesson, we're using the ESP32 Pixel board. This board is perfect for beginners to learn ESP32 and LVGL, and it's also great for building your own products. It has tons of features. I hope you'll like it. I'll put the link to the board in the video description. Thanks for your support. Before we start the lesson, if you're not sure where to download the code used in the course, you can click on the wiki entry on the website. On the top right corner of the wiki page, you'll find the link to Elunit's GitHub page. I'll put all the code, files, tools, and everything else used in the course into this repository, so it's easy to update and download. Just click the green button here, and you'll find the download link. Once you've got the course code ready, let's jump right into today's lesson. First, find the code for Lesson 5 in the course files and open it up using Arduino IDE. Right now, this code is the same as the one from the last lesson. We just need to make a small change to make it display the UI we designed. Currently, the code shows the demo provided by LVGL. Let's comment it out for now, and later we'll run our own designed UI here. But before that, we need a tool to design the UI. This tool is super handy. It's called Squareline Studio. It makes designing UI as easy as building with blocks. Open Google and search for Squareline Studio. Click on the first search result to go to their website. Then, click here, and it will take you to the download page. The latest version right now is 1.5.1. It offers versions for 3 different systems, so you can choose and download the one that matches your computer. I'm using Windows, so if you're on Windows 2, just follow along with what I'm doing. Alright, let's wait for the download to finish. Once it's done, we'll need to extract the installer first. Then, double-click to run the installer. Before starting the installation, you can click Option to customize the installation path. I like to keep all my software in the same directory, but if you don't mind, you can skip this step and just click Install. The installation process is super quick. It should be done in under a minute. Once it's installed, click Finish. Then, head back to your desktop, and you'll see its shortcut has been added. Let's run it. Here you can see that I have 26 days left on my trial, but actually Squareline Studio offers a 30-day trial. I installed and tested it 4 days early to prepare for this lesson, and then uninstalled it. Before the trial period ends, you can register and log in with an account to continue using it. Okay, this is a project I created during testing. I'll delete it first. When you open the software for the first time, you should see this screen. There are many examples prepared by Squareline Studio here. They're all beautifully designed UIs, definitely worth learning from. But for this lesson, let's start with the basics. First, click Create to set up our own project. Then in the Desktop section, choose the first option, which means we'll design the UI on a PC. Honestly, you can pick any of these options because we only need the exported UI file. Anything related to the architecture isn't necessary for us. Next, let's take a look at the project settings. Here's the project name. You can change it to whatever you like. I'll rename it to Test. Then, here's where you can modify the project's save path. My suggestion is to create a separate folder for each project to keep things organized. It makes everything much easier. Next is the resolution setting. Since we're using the ESP32 Pixel board, its resolution is 800 by 480, so we don't need to change that here. The angle and shape settings can stay the same as well. But make sure to adjust the color depth. Our board uses 16-bit color depth, so we need to set it to 16-bit here. I covered the screen details back in Lesson 2, so you might remember that. Finally, there's the LVGL version. You can check the version you're using by opening the Library Manager in Arduino IDE and searching for LVGL. Right now, we're using version 8.3.11. So we need to select the same version in Squareline Studio. This is why I recommended everyone to install this version when setting up LVGL in the last lesson. Finally, click Create. If this is your first time creating a project like mine, it will automatically download some necessary components. Once the download is complete, the project will be created automatically. This is what the screen looks like after the project is created. You can use your mouse to drag the edges of these toolboxes to resize them, or use the mouse wheel to zoom in and out of the screen view. Hold down the left mouse button to adjust the position of the screen. Next, let me briefly introduce the interface of this software. On the left here is the Widgets panel, which is packed with a variety of widgets. Once you get the hang of it, you can create a really nice-looking UI. Up here, it shows the number of current screens. If you want to add a new screen, you can find Screen in the Widgets panel. Just click it once and it will be added to the display area in the middle. Also, you can select any screen here. Once selected, the top of the screen will change from black to green, and when I add widgets, they'll be added to the currently selected screen. Once the button is added here, you can use your mouse to adjust its width and height. After adjusting, you can also drag it to change its position. In the Inspect panel on the right, you can modify the widget's name. Here I'll change it to BTN1, and you'll notice that the button's name in the Hierarchy panel updates to BTN. Besides the name, we can also modify other properties of the button, like its color. Click here, and we can change the button's background color to red. Besides the background color, there are more styles you can tweak. Next, I'll add a label to the button. You can see that this label can be moved freely on the screen right now, and its parent is the screen. But if I want to fix this label to the button, I need to change its parent to the button. The way to do this is simple. Just drag the label in the Hierarchy panel to the bottom right of the button, then release. You'll notice a small triangle symbol appears on the left side of the button. When we click this triangle, it will collapse or expand all the child widgets of the button. Now the label is already a child widget of the button. Now there are two ways we can modify the label's font. The first is through the label's Inspect panel, where you can adjust a lot of properties. The other way is through the button's Inspect panel. Select Button 1, and then find the text section here. Changing the text-related properties here will also apply to the child widget. However, it offers fewer options for modification. So let's continue by selecting the label and making changes in the label's Inspect panel. The current font size is too small. Let's switch to a larger one. 18 still seems a bit small, so let's go with 22. After adjusting the font size, we can also modify the text content displayed by the label here. Change it to Switch to Screen 2, then adjust the button size a bit. Next, to make the label's text more visible, I'll change its color to blue. Also keep in mind that the label's parent is BTN1, so if the label moves outside the bounds of BTN1, it won't be visible. Alright, since I need to implement a button to switch between Screen 1 and Screen 2, I'll also add the same button and label to Screen 2. Of course, to make it more intuitive to know which screen we're currently on, I'll add a label to each screen to indicate whether it's Screen 1 or Screen 2. Now, let's try clicking the triangle button in the top right corner to start the simulation. When I click the button to try switching screens, you'll notice nothing happens. This is because I haven't added an event to the button yet, so no matter how much I click it, it won't respond. So let's click the triangle button again to exit the simulation. Then, in the Inspect panel, find the Add Event button. But before that, make sure you've selected BTN1 to ensure the event is added to BTN1 and not Screen 1. Then, click it. After the event is added, we still need to set how the event is triggered. For buttons, I usually choose Release, as it's more accurate. Since I want to use the button to switch screens, for the action after triggering, select Change Screen, then click Add. Once the event is added, we need to fine-tune the details of this event. For the switch action, choose to switch to Screen 2. The face mode can be selected based on the effect you prefer. I'll keep it as the default here. The duration will also stay the same. Similarly, let's add a similar event to the button on Screen 2. But I want to change the trigger method to Long Press. The action will still be switching screens. Click Add. Then fine-tune the action settings. switch to screen 1 and change the fade mode to move left. This way, when I press the button on screen 2 will slide out from the left and screen 1 will slide in from the right. Finally, change the duration to 600 to increase the screen transition time, making it easier for us to see the effect. After the events are added, let's click the simulation button again to run it. Now when I click the button on screen 1, it finally switches to screen 2. And on screen 2, I can long press the button to switch back to screen 1. Since the trigger method for screen 1's button is release, it won't trigger if I hold the button down. It only triggers when I release it. As for screen 2's button, the trigger method is a long press, so no matter how many times I short press it, it won't trigger. Nice! This is exactly the effect I wanted. Doesn't it look fun? Alright, next we need to export the designed UI into code. But before exporting, we still need to set the export path and rules. Click File, then open Project Settings. The top part here was already set when we created the project, so no changes are needed there. Next, let's set the project's root directory. I usually set the root directory to the folder where the project is stored, and I recommend you do the same. Then, there's the export path for the UI files. All the code we export will be saved in this path, so the best approach is to create a folder named UI within the project's root directory. It makes things easier to manage. Next, for the LVGL include path, based on Arduino IDE's structure, we just need to enter lvgl.h here. Finally, scroll down and find Flat Export. Check this box so that when we export, all the UI files will be exported into a single folder. Next, all we need to do is export the UI files and then find them in the specified path. Click Apply Changes to complete the settings. Then click Export and select Export UI File to convert the UI into code. To make it more intuitive, I'll first open the folder based on the UI file export path. You can see that this folder is currently empty. There's nothing in it. But after I click Export UI File in Squareline Studio and reopen the folder, you'll notice many files have appeared here. The ones we need are only the files with .c and .h extensions. These are the UI code files. We just need to copy these files, navigate to the directory of the code we're using for this lesson, and paste them here. Now, when you open Arduino IDE, you'll see that the UI code has been added. The UI code is now imported into the Arduino IDE project, but how do we actually use it? It's simple. We just need to call one function. Open the UI.h file and find the UI_init function. This function contains the initialization code for the entire UI, and its implementation is in the UI.c file. As you can see, the code in this function initializes the two screens we designed in Squareline Studio and, after initialization, loads screen 1. So, all we need to do is call this function in the setup function to load the UI. Go back to the setup function here, and replace the previous call to the LVGL demo function with UI_init. That's it! However, since we used a size 22 font when designing the UI in Squareline Studio, and LVGL only enables the size 14 font by default, we need to enable the size 22 font as well. Click File, then open Preferences. Copy the library directory path. Then navigate to this path. Open the library directory and find the LVGL configuration file, lvconf.h. Open it and search for Font to locate the font usage section. You'll see that only the size 14 font is enabled by default, while the others are not. Find the size 22 font and enable it. Then, save the file and close it. Now we can configure the build environment and upload the code to the board. First, connect the Pixel board to your computer using a USB-C cable. Then click Tools and under Board select ESP32S3 Dev Module. Next, in Port, choose the serial port that the Pixel board is connected to. Third, in Partition Scheme, select Huge App. Finally, in PSRAM, choose OPI PSRAM. Now the build environment is set up. Click the Upload button to upload the code. But due to my oversight, I forgot to make an important change which caused a compilation error. This is because my current code uses the UI_init function, which is declared in UI.h. So I need to include the UI.h header file in the main file. Otherwise, it will throw an error saying it can't find the header file, resulting in a compilation failure. Now, when I compile again, it works fine. The compilation process is quite long, so I'll skip this part. Once the code is compiled and uploaded to the Pixel board, the board will automatically reboot and display the UI I designed in Squareline Studio. Also, when I try triggering the button events using different methods, the results match what I set up. Looks like it's a success. The whole process is very straightforward. If you're also learning LVGL, you can follow along with this video step by step, and I believe you'll design even more interesting UIs. Alright, that's it for this lesson. If you enjoyed this video, please give it a like or subscribe to my channel. I'll keep updating more video tutorials for you. Thanks for watching, and see you next time.